viewers, welcome to my YouTube channel, Maths with David and Victor Adewale Adeleke. Yeah, our major focus is to teach you mathematics from the onset, even up to tertiary institution. If you are yet to subscribe to my YouTube channel, do well to subscribe, like, and share. It is very important so that whenever we post helpful materials like this, you will always get notified. Okay, following my playlist, I've been teaching calculus recently, and I think I already explained how I derived this particular function. This is what we call the definition of a derivative, or it can be called the first principle in differentiation. So today I want to use this time out to quickly explain how to find, this is a trigonometrical function which is the cosine of x. So we want to find the function, want to find the derivative of this function, the cosine of x, to see what the answer will come out to be. So we have that the function of x, which I already told you, is y. If you have not been following my series, go back and check my videos. I explained how this proof came about, and I also explained why this function of x can also be called y. I also talked about that this function of x can also be represented as the y axis. So that is that. So now let's quickly find the, out of the many other methods that can be used to show the derivative of the cosine of x, which is a trigonometrical function, this definition of a derivative has proved much effective and even more simpler to solving this problem. There are so many other methods or methodology or approach to providing the derivative of the function of x, the trigonometrical function of cosine of x, sorry. So, but this particular one, using the first principle, is a very smart and fast, explicit way to do it. Now, I'm going to try to see what we can do. These are, just first of all, before we do that, let's note all these functions. These two are called standard limits. Whenever you are limiting h, whenever you are limiting when h is tending to 0, the sign of h divided by h. Mind you, h is not the hyperbolic function, no, but h is the increment in x. Note that if you are not familiar with the h I'm talking about, go back to my first video. The link will be given at the end of the video, or probably at the comment section for your convenience sake. So this is it. So the sign of h divided by h. The h is not hyperbolic, as I said. The h is the increment in x, in the x-axis. So this is the limit of h tending to 0. Sign of h divided by h will give you 1. That's a limit function, a standard limit. Then the limit of h, the limit as h tends to 0, the cosine of h minus 1 divided by h must give you 0. Then another one you must note. These are the three things you must note before you can provide a solution to that. Then the cosine of a plus b, this is a trigonometrical identity or formula. Cosine of a plus b equals to cosine a cosine b minus sine a sine b. So let's see how we are going to use this information to bring out the derivative of the function, the trigonometrical function cosine x. So let's see what we can do. So following that, I've already explained, I said, since the function of x is equal to cosine of x, then the increment, the function of x plus h, must be cosine of x plus h. If you understand further mathematics, function, particularly the topic, you will know what I'm doing there. So let's see how we're going to bring out the derivative of the cosine of x. Now, what do we need to do here? Just say dy dx will be equals to the limit as h tends to 0. What is the function of x? Now, the function of x is the cosine of x plus h. Then what do we have? Minus what? Minus f of x, which is the cos x. Okay, all divided by h. Then everything here will be equals to the limit as h tends to 0. What is the cosine of x plus h? It's going to be represented with this identity here. So we're going to say, therefore, that this is going to become cos x, then cos h, minus sine x. Then what do we have? Sine of h. Then minus what? This minus now. This is, don't forget, all this is what we represented. So this minus is the minus we are having here. Then what do we have? The cosine of x. Okay, I'm trying to minimize space. That's why I'm doing all this. Okay, so we have it all ruled out. Then what do we have? We have h. Now, if you watch properly, I don't want to waste too much time. You can see we have the cosine of x and the cosine of h. The reason I'm bracketing the h, the reason I'm bracketing the h is because The reason why I'm bracketing the h is because the h is not an hyperbolic function, like I said. So the h is the increment in hex. That's the reason why I'm bracketing. Because if I don't bracket it, you will be confused and feeling like that is a cosh, or that's an hyperbolic cos, which is not supposed to be. This is not an hyperbolic cos or an hyperbolic cosine, but this is the increment in x, cosine of the increment in x. So that is the h. So it could be dx if you wish. If you wish. So we have the cosine of x, the cosine of the increment in x minus this, all of this. So now what do we do? Now you can see we have cosine of x here, we have cosine of h, we have cosine of x here. So we can bring them close together. I just want to jump that. I just want to skip some part. That's the reason why I'm trying to minimize the space. So I'm just trying to I'll factorize. If you understand, this is just pure algebra that I'm doing. I'm just trying to follow the algebraic steps to make sure I minimize my steps and come out with the solution. So the limit as h tends to 0. Then what do we have here? We have the cosine of x. We have the cosine of x. So when they come together, we can factorize the cosine of x. Then we have a bracket. We have just the cosine of the increment minus what? Minus 1. Minus 1. Then minus just this one now, which is the sine of x. Then the sine, sorry, of h. Then all divided by h. But there's something I want to just do here. Since we know that everything, we have a minus here, and these two are held together by a product, and these two are also held together by a product, rule. So we can just clean the minus, the brackets, the division sign, the division line, as simple as this. And we can see h. We can put your h there, and we can also put your h here. So we can separate these two into two different functions, of which they are still the same algebraically. They are still very the same. So we just separate them. So we have h here, which is the increment in x, and we have the h here, which is also the increment in x. So if you break this down, if you break this, if the limit goes into the bracket, we have that dy dx. Okay, we have that dy dx will be equals to the limit as h tends to 0. So the limit, it will affect this first. So we have the cosine of x. Then what? The cos of what? Of h minus 1. All we can represent it as all divided by h. Then the minus, which is this minus sign. The limit is still going to affect because the limit has expanded the bracket. As h tends to 0, we still have the sine of x. Then we have what? The sine of h, which is the increment in x over h. So this is what it is. So you can see now that the limit of h tends as the limit as h tends to 0, the sine h divided by h must become what? Must become 1. So which means that everything here represents 1. So we can just say that therefore dy dx will be equals to everything here is 0. So we have everything because of the limit of this, it becomes 0. So hope you know this can also be written as, okay, let me not confuse you. This, so that you don't think maybe I'm doing anything wrong. These are all held together by product. So we can do something like this. We can put the limit here as h tends to 0. The limit, sorry, okay, yeah, the limit as h tends to 0. Then we have the cos of x here, still the same as what we had the other time because they are all held together by product. And since everything here represents 0, we can say the cos of x 0 minus what? Everything here the same thing. You can arrange them like that if you wish. Still means 1, which is as given here. So which means that everything here terminates, leaves the what? The brackets. Everything here terminates. Then we have just our what? Our minus sine x times 1. So we come out finally with the minus, the negative sine x. So whenever we are given a function, the trigonometrical function cosine of x, and we are told to find the derivative, is going to come out as the negative sine x. This is an explicit show of the proof using the definition of a derivative. If you are yet to subscribe to my YouTube channel, do well to subscribe, like, and share. It is very important so that whenever I post a full material like this, you always get notified. Stay tuned.